So usually what I'll do is I'll give these talks where I'll focus on one project, but instead today what I'd like to do is just kind of give you an overview of some of the work that we did over this past growing season. There's several different projects going on, but I'm going to focus on Cotton Commission funded work and Cotton Incorporated funded work. And so what I'll be talking about today is Seedling Vigor, nitrogen, and robots. Okay, so we'll get to that kind of at the tail end here. But Seedling Vigor and nitrogen there, I'm going to try to sort of tie these two things together, okay? So there is a sort of school of thought that if I've got two different varieties, okay? I've got one variety that has a high lint percent, small seed, and I've got another variety that has large seed, lower lint percent, but they've got the same yield. In theory, the one with the larger seed should require more nitrogen because the seed is the dominant nitrogen sink for the plant. Okay, so there's some papers out there on this and some arguments that that's sort of how this would work. However, we also know that larger seeded varieties tend to be more vigorous. Okay, tend to have more vigorous early season growth, and that could potentially influence how efficiently those varieties utilize available nutrients, water, whatever. Okay, so again, I don't think it's just as straightforward as saying, well, this larger seeded one requires more nitrogen for the same yield. But again, we have to evaluate these types of things. So this was a Cotton Commission funded project where we looked at cultivars with broad differences in seed characteristics and evaluated their response to nitrogen. But in any of this type of work, I think if we're going to evaluate that and we're going to look at seed size, we need to also be looking at seedling vigor as well. So we know that seedling vigor is important because it improves competitiveness with weeds. It allows that plant to rebound from early season stresses better. And then we also know that cold temperature can negatively impact seedling growth, can decrease vigor, and more vigorous varieties tend to do better under those lower temperature conditions. All right. And so some of the research that I've done, working with Dr. Whitaker, has evaluated the impact of seed characteristics on vigor, seed size, seed oil content, and we find positive associations with seedling vigor. And so what we did is we took about 20 varieties that were in the on-farm variety trial for 2017, and we took subsamples of those and analyzed them for seed oil, protein content, looked at seed mass as well. And so we picked the extremes, okay? And I'm not doing any of this to kind of tell you this variety is better than that variety or so on and so forth. Or this company is better than that company. There's no that's not my purpose here today. We just screened all of the varieties we had for seed oil, protein content, size, and we got the extremes. We got the larger seeded stuff and we got the low in here. So there's a pretty good bit of variation here. I've got it in milligrams per seed. We've got 118 milligrams per seed versus 72.2 up here. So there's some pretty big differences if you think about that as a percent in terms of seed mass. And so what we did first, before we did any of the field work this growing season, we conducted this controlled environment experiment with two different growth temperatures, an optimal temperature and a suboptimal growth temperature. I'll get into some of that here shortly. And then we evaluated several different parameters. So we evaluated seedling vigor looking at leaf area, looking at plant height, looking at nodes, and especially looking at dry matter. That's kind of per plant dry matter is sort of the gold standard if we're going to evaluate seedling vigor. And I've made a little note here about root growth and anatomy because this is something we rarely ever look at, mainly because it's kind of a pain to evaluate root growth and anatomy. And so I happened to have a postdoc visiting for a short period of time, and I was like, hey, I've got something for you to work on. And so we actually have quite a bit of data on root characteristics as well. But the first thing that I want to mention, the first part of this project, was to use some of the tools that we have available to us as physiologists. So this thing right here is called a fluorometer. I can clip it to a leaf, I can push a button, and I'll get like 20 different parameters at one time that I can use, and it'll tell me something about a photosynthetic process in that plant, okay? And what I wanted to know is, can I use this rapid screening tool to detect differences in vigor, okay? That's sort of what I was interested in. That's the first part of this project, okay? So with that in mind, I had several different ANOVA tables and and graphs that I was going to show you, but I thought this is pretty straightforward, okay? We had under the optimal temperature condition, obviously we have what? We have bigger plants, more leaf area, they're taller, they've got more nodes, so none of this is a shocker, right? None of this is surprising to anybody in here. Low temperature negatively impacts early season growth, okay? And then if we look at these tools, this fluorescence-based tool, don't worry about what these parameters on the x-axis here are. Each one of them tells us something important, for me as a physiologist. But what is important is if you look at Seedling Vigor, as far as look at it as grams of dry weight per plant, we get some very strong relationships between these fluorescence parameters, and this was just measured on cotyledons, and dry weight per plant. Now some of this is temperature, obviously a lot of this is temperature related, but it is encouraging to see that this tool, that's a pretty rapid screening tool, could be used to detect differences in whole plant growth, okay? So that's the first part of this. The second part of this is looking at root growth. So again, got lots of graphs to show you the temperature effect on roots, but I think this is pretty straightforward, right? It is not uncommon to plant cotton under these conditions, okay? No matter what we say you should do, it's not uncommon to put cotton in the ground under these conditions here, these suboptimal temperature conditions. But you can just see the effect this has on root growth, right? I mean, it's a tremendous impact on root growth. Overall, every root growth parameter is negatively impacted by low temperature, except root diameter, okay? Root diameter shows the opposite trend. Any of you who've ever looked at a cotton seedling, pulled it up, and you've got some sort of chilling injury, that primary root will be thick, right? And so that's, I'm not gonna, like I say, I'm not showing all the graphs, but that's what we saw here, okay? But you can see how low temperature negatively impacts root growth. When we looked at these varieties, there's obviously variety differences, not in taproot length necessarily, but if you look at the number of secondary roots, okay? We do have significant differences here in vigor. So there's significant cultivar variation. That's all I'll say is there's significant cultivar variation. I do want to kind of focus in on that secondary root number because that leads into the anatomy portion of this talk. Okay? So along with all these different root traits that we measured, we also, this postdoc, what she was actually more interested in, was looking at xylem anatomy. Xylem is the tissue that brings water and nutrients to the rest of the plant from the soil. And so let me just kind of move into that next, okay? Most cotton that we have, okay, it has in the root, there'll be this central vascular bundle here, okay? And this is the vascular tissue that brings water and nutrients to the rest of the plant. And so this is the xylem right here in the middle. It looks like a cross, okay? Most varieties, most any cotton you'll look at will have this arrangement. Looks like a little cross here. The lateral roots, the secondary roots, come off of each one of these arms that are sticking out here, okay? That's where they'll originate. There's a meristematic tissue that gives rise to that. So what is really interesting is just out of pure luck. So we took 20 cultivars, trimmed it down to 6, and then, of course, this is really time consuming, so she trimmed it down to 3, just picking the extremes. Again, just by pure luck here, we found one, and this has been documented in the literature, mainly looking at some wild cotton germplasm and whatnot, but we just happened to find one here that had the 6 arms sticking out of it. Had that unique sort of polyarch structure, the 6 different arms there. So in theory, it should produce more secondary roots, okay? That one's Stoneville 5020. If you remember the secondary root numbers stuff, it's right here at the top, okay? Now, there's other varieties that are close to it and so on, but the point is it's really interesting to see that internal anatomy matches up pretty closely with what we're seeing in secondary root number. All right, so that's early season root growth. And then this was really the main purpose of the project, was to evaluate seedling or cotton response to nitrogen rate in these different varieties that have broad differences in seed mass. That was the original purpose of the study, but we did all this preliminary work leading up to it. And so each color is a different variety nested within a nitrogen treatment within a rep, okay? This is how the study's laid out. It's a big study. Problem with big studies is you put them in large fields, and those may not necessarily, those fields will have some variability in them. And when we get high rainfall like we did this last year, and then some variation in slope in that field, rep ends up being our main factor that's influencing our variability then. So we have our first rep. That's a pretty low yielding rep. If we take all the cultivars, all the nitrogen rates, lump them together, rep is, the first rep's pretty low yielding. And then, oops, let me back up. And actually these yields are a little underestimated because we had pulled a 6-foot sample for yield component analysis from each of these beforehand, and I didn't factor that into this graph. So these are a little underrepresented here, but either way, you can see that there's definitely a rep effect, okay? So there's that. So think of that, that's where most of our yield variation was in this field. So it's unfortunate when you're looking for a nitrogen response and you get all this rainfall and you get more of an effect of location within the field, okay? When we run the analysis, we do see some differences in varieties. So okay, this is showing some are higher, some are lower, and yes, I've started my axis at 400 to make it more obvious to those of you looking at this. But look, we're not seeing these huge differences here, right? It's just saying across all treatments, these varieties had higher yields, okay? If we treat each rep as a unique yield environment, okay? So I know that a particular rep was really crappy looking. That cotton was clearly nutrient deficient. I mean, it's a nitrogen trial. I can't go back in there and throw more, nitrogen on it, or else I alter my results, right? So if I treat each rep as a unique yield environment, and I plot average cultivar yield versus the yield for that unique yield environment, this is what's fascinating to me, okay? So we got 50-20 here, we've got 61-82. All I want to point out, it's not to say this variety is better than that variety. It's that the ones that had the most aggressive root growth early on, I put them in this rough environment here, and they out-yield the stuff that's more responsive, okay? At the high end, there's a yield penalty, okay? So, you take the Ferrari and put it on the highway, it does great, okay? You take it and you take it off road, put it in a pretty rough situation, it's not going to do the same, right? And so if you've got yield stability versus, what is our potential of that variety? And so you were talking about, all right, we've got this variety that's a really high yielding variety, but if you don't put it in a high yield environment, you don't see those benefits, right? So it is interesting to me, some of them are more responsive than others, have a steeper slope. And then the ones that were more stable across environments had the more aggressive root growth. Now, I'm going to move on from that. I got several things I'm talking about, but I want to move on to this next thing. There is an interest within Cotton Incorporated to look at robotic harvesting, having a swarm of robots that are out in the field picking cotton bolls as they open, because once that, you got that cotton boll that opens, that fiber dries, that fiber quality is going to be as good as it'll ever be, okay? And so the idea is, if you're picking cotton as it opens, then you get this premium. You'll get better fiber quality, okay? So this is something it's of interest to Cotton Incorporated. I don't know anything about robots. I'm a physiologist. I can measure certain things. I'm not an engineer. I'm working with some engineers. But what we can do is we can pick cotton throughout the season, and we can evaluate if there's really any benefit. Do we get a benefit in fiber quality, okay? Now, I don't have all the fiber quality data analyzed, but here's what we got, okay? We compared a single hand harvest at one time, same time that we machine pick, to a one-time machine harvest and then a multi-harvest, okay? Where we were picking 2 days a week, all right? It was pretty labor intensive, not for me, it was for Lola, okay? Lola and other members of my group, okay? They were out there picking 50-foot a row every couple of days. So anyway, they really appreciate that we're going to be doing this again next year. So if you look at these trends, all right, you can see this is for the multi-harvest. You see yield development over time. You see how much yield we get at each harvest time. What I want to point out here is Georgia. This was done at multiple locations throughout the Cotton Belt. Georgia was the only location that showed a significant yield benefit to the multiple harvest method. Why?
Because we grow better cotton every month. Longer growing season.
Something really unique to this growing season. It's not unique to this growing season, but we had a pretty, what else? Somebody else. They're wrong. What else?
Hurricane.
Huh?
Stress.
Okay, stress. What kind of stress?
Weather. Water.
Weather. What kind of weather?
Hurricane.
Hurricane. Absolutely. We had a hurricane that came through. If you will look at this harvest timing, look here. We got a big space in here. It's not because Lola was being lazy and just didn't go out to the field and pick cotton. We had a hurricane that came through, right? So if you think about this, we already got all this cotton out of the field. It's not sitting there to be knocked off the plant, right? So there is a potential benefit here, not just in fiber quality, but yield, especially in situations where we have tropical storms. Again, the logistics of how all this is going to work, I don't pretend to know anything about that, but this is an interesting observation, if nothing else. But we haven't looked at, again, all the fiber quality stuff yet either. I'm done talking. You have any questions? Again, I don't know how much Jared said I needed to wrap it up in 15 minutes. I don't know that I did that, but anyway.
So John, if we didn't have a hurricane, would you see the same thing?
I've only done it once.
What's your thought?
Well, I would say no, because this project was done throughout the cotton belt. So I don't think we would necessarily see that yield benefit, but at every location they're evaluating this at, they are seeing some fiber quality benefits in terms of, loan value and things like that. Anything else? All right, that's all I've got.
All right, glad to be here. Jared wanted to go last, so I'm going second. But a lot of y'all may not know me. I'm Mark Freeman. I'm Jared's extension counterpart in East Georgia, based out of Statesboro and Midville. But I'm just going to talk briefly about 3 projects that we had going on in East Georgia this year. One is just a relative PGR variety response, and then a harvest timing study, and then spend a little bit of time on a cotton management systems trial that we did. So just briefly, Jared's going to talk varieties later. The variety selection we all know is critical for everybody in Georgia. And one of the components of variety selection is how do we manage these new varieties? If you've never planted a variety, you don't have any experience with PGR or any other component, but what we try to do is do a PGR test and kind of correlate how would a variety fit, compared to another variety that you've planted in the past. So this year I had room for 10 varieties, had 8 that were commercially available and 2 that were experimentals that'll be available next year. Just a small plot trial, 3 reps, but each variety was evaluated in 4 PGR PICS management systems: a 0, a one shot, which would be at first bloom, a 2 shot, which was at first bloom plus 2 weeks, and then a 3 shot program, which was at pinhead square, first bloom, and 2 weeks after first bloom. The data that we collected were end of season plant heights, nodes, and seed cotton yields. And I don't want you to dwell on the charts. I know it's complicated. If you really want to study each variety, there's a poster outside, you can do that. But what we want to do is just take this data and fit a variety onto an easy to use chart. Okay, so I have some of these charts with me. Jared, are we doing pesticide credits?
Yes, it's right before lunch.
So I'll have these set out. When you do your pesticide credits, you can just pick one up. But all we want to do is say, okay, I'm going to plant this X new variety, never planted it in the past. I've planted this variety before. This new variety is going to react pretty similar to the old variety. So it gives you just a guide, just a gauge on how you can fit that variety. Now, I always want to stress that we only want to use this as a guide. So any variety in the high category, if it's got dry conditions, really sandy soil, low fertility, we're going to have to manage our picks based on all those factors. Variety is just one small component of the whole program. Okay, so I do want to stress that. Now moving on from that, talk a little bit about harvest timing. If any one year was the perfect year to do a harvest timing study, I think 2018 was it. These type of studies have been done, in the past. Dr. Snyder's done them, Jared's done them. And what you see a lot of times is if you don't get any rain, you don't see any yield loss or any quality loss. But in 2018, we did a large plot trial in Midville. And we defoliated the trial all at the same time, and they came in and harvested at different intervals following defoliation. So the first harvest was 14 days following defoliation on October 18th, and our last one was 40 days following that, which would be November 28th. Okay? So a pretty good stair step. It's a 40-day window from the first to the last. Now, like Dr. Snyder said, there was a gap, between two of them where we tried to do it every week, but we had a couple weeks of delay right here due to rainfall. But if you look from the very first to the last, we had a total of 107 pounds lint loss in that 40-day window. Okay, if you want to look at it on a percentage base, that was 11% of our total yield. Okay, and I would guess and I would argue that if it weren't for Hurricane Michael, this slope would be even greater. I think we lost probably some of our more weatherable cotton to the hurricane, but it's still, this is important. We'll skip that one. But the another important factor is what about quality, and how does quality impact this? So I went in and I put a loan value. I got the fiber quality analysis. I put a loan value on every single plot, and then I did the quality plus the yield and got a loan value per acre. Now the biggest factor that we had here was staple, mite, strength, and uniformity basically stayed the same, and our color went from a general 31 on almost every plot to a 41 on every single plot here. So we still were in a technical, we still had a premium, but it was a 2 cent less premium when we were here and here. So when we look at the money, we had a loss of $71.71 over that 40-day period, which was about $1.96 per day. So pretty significant. I mean, we stress harvest timing every year. And in Georgia, we know we have peanuts that interfere with that. Peanuts are are more sensitive to harvest timing. We know that, but we do need to stress cotton, the importance of cotton, and being timely. And this 2018 was, we all know what kind of year we had. Now, this trial I'm going to spend a little bit more time on. This was a systems trial. Just to give you a little background on it, I was with a grower, and Jared was with the grower, and we were just talking, and he mentioned just putting out insecticide and fungicide on a calendar basis, and I happened to mention, well, where are you at threshold? And he said, oh, I don't have time for all that. Nobody has time to scout 3,000 acres. And to me, it was kind of alarming. But when I sat down and thought about it, I think you can classify every grower in the state into one of 3 categories. And all 3 are probably in this room right now. The first category, they're going to do exactly what UGA recommends, exactly what the county agent recommends, probably the minority of growers. The second group is going to say, I don't have time for that. I'm going to put out everything. Plus, I listen to my retail guy instead. It is what it is. And then the third category of growers would say, if you put out everything that UGA tells you to do, you're going to go broke. They tell you to put out too much. So there's really 3 different categories that I think everybody in the state would fit into one of those. So I want to do a systems trial, and I'll explain what I mean by the systems trial on the next slide. But we did this in Midville on a large plot basis. We had in Midville we have a drip tape field where we can alternate for different zones. We can alternate our irrigation strategies, and it was a randomized complete block design. Had 3 reps. So this was our systems. These are our treatments. The first one was strictly UGA recommendations, and this is for the whole program. So this is everything from seeding rate, fertility, irrigation management, IPM strategies. The second was a kitchen sink or high inputs approach. which is just basically putting out everything that you can put out based on the calendar. And the third was a low input strategy where basically just did as little as possible and tried to save as much money as possible. So the first slide I'm going to show is the yield. It's pretty much what you would expect. The high input situation, you're going to have more yield, and we did. It was a little more of a gap than I was expecting, but we had statistically the highest yield in the high management system. The UGA and the low weren't statistically different, but numerically, it's basically how you would imagine. Okay, so now I'm going to go through some of the inputs, and this first slide is all the inputs that were the same among all of them. So our pre-plant fertility was all the same. Our herbicide strategies, I didn't want to change anything on it. I left that all the same. And our defoliation strategy, I left all the same. Now the prices that I got are straight from our UGA cotton budgets. I worked with Serena on these, and so your prices may be a little bit different, but this is what I got from the budgets. Now for the treatment inputs, I'm going to go through them all. The first one is our side dress nitrogen, and this was my one mulligan. Me and Anthony Black, the station manager, had a little bit of a miscommunication. So our UGA and our low had the same fertility treatment. We were able to put out just extra nitrogen on the high end. Seeding rates for UGA, I used 2.5 seed per foot. Compared to the high, I used 3 per foot, and the low, I used 2 per foot. Aldicarb, put out AgLogic at 5 pounds on the high end. We were negative for nematodes through nematode testing, and using our thrips predictor model, we were at low thrips risk, so I didn't use Aldicarb for UGA. Throughout the season, I put out one aphid treatment, imidacloprid, on the high end. I put one pre-bloom application of PIX on the high end. For stink bug, I used the 357 approach for the high end. We went over threshold only 1 week, so at UGA I applied it at 1 week, only 1 week. PIX for UGA, did it at first bloom and then 2 weeks following that. Only once in the low,